Today I'm going to finish the time value of money discussion with a brief look at present value. But before we do that, let's review the previous assignment. The previous assignment out of Appendix 3, in the first part of the assignment, there were 4 parts here, A, B, C, and D, but I only asked you to do parts A and B because those were the future value parts. Part A wants to know the future value of a single cash flow of $5,000 that earns 7% interest compounded annually for 10 years. So this is going to be the future value of a lump sum. We know the present value. The present value is $5,000, and it's a single cash flow, so it's a lump sum. And so we're just going to, what would it be? What would be the future value if we invested it for 10 years and that investment earned 7% interest? So we're going to need the future value of a single amount table, which I had uploaded in a previous class into the Blackboard content folder. And in that table, we would need I equals 7 for the interest rate equals 7 and N equals 10 because it was 7% for 10 years. So if you come back to this table, you may not be able to see it very well, but if you open up the PDF file where you can zoom in on it, you could see it. 7% for 10 years is a factor of 1.96715. So I'd simply take that and multiply it by the 5,000, and that would give me the future value of, it's rounded here, but $9,836. I realized in the textbook they wanted me to round it to the nearest penny to 2 decimal places. Not really interested in that. I just want to get a general idea of what it's worth here, and a few pennies is not going to make a difference on 10 grand. So $9,836 is fine for an answer. In part B, this is also a future value, but this is an annuity because now the calculation is for 10 cash flows of $500 each, meaning each year for 10 years and earns 7%. So we have the same I in the N. We have an I of 7% and an N of 10 years. So we have the same percentage and N coming out of the table. The factor is going to be different though, because now we're looking at the future value of an annuity table. So we're going to need this table, which I uploaded in the prior class's Blackboard file. Again, it's kind of hard to see here, but if you open up that PDF, you can zoom in on it. It's 7% at 10 years, which looks like 13.81645. So I would multiply that by $500 of principal, and that would give me a future value of the annuity of $6,908. So as usual, you can let me know if you have any questions about those answers or what you did. And now on to the new stuff as promised. Present value calculations are for both lump sums and annuities, right? We can do lump sums and annuities for future values. We can do the same thing for present values. Either we have one cash flow at a point in time, or we have a series of equal cash flows over time. Present values are used when we know the future value, but don't know how much that future value is worth right now. So notice how we contrast that with a future value problem. In a future value problem, we know how much we have right now. Like in letter A, we have $5,000 right now. And we want to know how much it's going to grow to in the future. And that's why it's called a future value problem, because you want to know the future value. A present value problem is kind of the opposite of that, if you will, where you know what you want to have in the future, but you don't know how much that's worth right now. So since you want to know what it's worth right now, you want to know the present value, and thus these are present value problems. The tables are going to look very similar to the future value problems. You're going to have a present value of a lump sum table and a present value of an annuity table, which you will use depending on whether it's a single cash flow at one point in time or whether it's a series of cash flows over time, just like with the future value problems. The only difference is I don't know what it's worth today, but I do know something about the cash flows or the future value, but I don't know the present value, and so that's why these are called present value problems. So here's an example. A married couple wants to have $60,000 for a down payment on a home 5 years from now. This is a very common thing for newly married couples to do. They typically want to buy a house, and so houses generally require down payments, and even if they don't, you should have a down payment. And they want $60,000. Now, that's what they want to have for a down payment on a home 5 years from now. So notice here, they know the future value. They want to have $60,000 5 years from now. So generally with these problems, in this example, and it's very common, you have some sort of goal, right? You want to have a certain amount of money in the bank at a certain future point, whether it's for a down payment on a house or maybe to buy a new car or maybe to do something else with. But you have a goal that you want to get to in the future, but you don't know what you need to do today in order to get to that goal. And so this is a very common problem. Now, we know that it's going to be for 5 years, so we know that N is going to be 5. And we're going to assume that any money they invest today, we don't know how much they're supposed to invest today, but any money that they would invest today, they could earn 8% on. So the I is going to be 8% and the N is going to be 5. So the question is how much money would they need to deposit today to meet their goal? Well, the answer cannot be 60,000, right? If you put 60,000 in the bank today and you leave it in there for 5 years and it's earning 8% interest, then you're going to have more than 60,000 in the future. So the answer is it's got to be something less than 60,000, right? If you put in something less than 60,000 at 8% for 5 years, it will grow toward 60,000. So for instance, if we put in, like $10,000 today in the bank, it's going to grow for 5 years at 8%. Now it's going to grow, it's going to get bigger, but it's not going to get to 60,000. It's not going to, you're not going to get 6 times your money in 8% on 5 years. So the question is how much do we need to put in today in order to get to the goal? I know it's something less than 60,000, but I just don't know exactly how much. So this is a present value problem. Now it's a lump sum problem because the couple, they know how much they want to have in the future. They don't know how much they need to deposit today, and they're only talking about putting money in the bank today, right? They're talking about putting money in one time today in order to get to that amount. They're not asking how much do we need to put in the bank each year in order to get to 60,000. That would be like an annuity problem. We're not talking about that. We're talking about what do we need to put in the bank today? What's the present value of the money today that we need to put in so it will grow to 60,000 in the future? So we're going to need the present value lump sum table for this. And again, just like with the other tables, I've uploaded this PDF into Blackboard for you. I did have a student let me know that they wanted to just use the formulas at the top. And here you can see the formula for present value is 1 over 1 plus I to the n power. And that's certainly fine if you want to use the formulas. Or some people sometimes will have these buttons on their calculator. So you might have financial calculator options or financial calculator buttons on your calculator, where you can do these present and future value calculations that way. You can also do them in Excel, right? Excel has formulas for present value and future value. They have functions. You can look those up. And I bring this up because the student who let me know that they were going to use the formula let me know that when they use the formula, the answers are sometimes a penny or two off from what I get. And that's true, right? The tables that we're looking at here, these decimals are all rounded. They're rounded to 5 decimal places. And when you use the formula or you use a financial calculator or you use Excel, they're not using rounded decimals. Those formulas or software or whatever the case may be, calculators, they're using unrounded decimals. And so sometimes the answers will be a penny or two off from what I would get. Don't worry about that. That's not an issue on a homework assignment or on an exam. It's not going to be a problem. So that's okay. In any case, if you're like the majority of students, you're just going to come to the present value table, and we're going to look for, I believe it was 8% and 10 years. So yes, it's I equals 8 and N equals 5. Sorry, it's 5 years. I equals 8 and N equals 5. So we're looking for 8% on 5 years. So I would go to the 8% column at the top of the table, and then I would come down to row 5, N equals 5. And when I zoom in on that, that's going to look like this. You can see over on the right side of the screen in the blue rectangle, I have a factor of 0.68058. Now, if you're thinking about this, you'll notice that I'm multiplying by a number less than 1, right? It's smaller than 1. So when I multiply by a number less than 1, it's actually going to make the product smaller. So if you take 60,000 times 0.68058, you're going to get an answer smaller than 60,000. But that should make sense because, as we talked about just a few minutes ago, if I want to get to 60,000 in the future, I'm going to need to put less than 60,000 in the bank today in order to get there. So when I run that number through the calculator, I get $40,834.80. So if the couple invested $40,834.80 today in an investment account that earned 8% interest and they left it in there for 5 years, at the end of 5 years, they would have the $60,000 down payment that they would need for their home. Okay, let's look at a present value of annuity problem. And this is a common annuity problem for present value. You win a lottery. Congratulations. And you're given two choices for your pay. You can either take $100,000 today, or you could take $12,000 every year for the next 10 years. Now you might say, well, if I take $12,000 every year for the next 10 years, that would be $120,000. And that would be correct, but that $120,000 is in the future, right? So that's not $120,000 today. And as we've talked about in this particular section of the class, present value and future value they're two different things. So 120,000 in the future is not the same thing as 120,000 today. So what we need to do is we need to figure out which one of these two has the greater present value. And whichever one has the greater present value is the one we should pick. So you already know, whether you know it or not, you already know the present value of taking $100,000 today. You know, one of your two options for winning the lottery is you could have $100,000 right now. And $100,000 right now or today means the present value of that money is $100,000. It's the $12,000 that's kind of the problem, right? It's the $12,000 each year. So each year is a code here for an annuity. And we're going to take that money for the next 10 years if we take this option. So we have to make an assumption here about what we could do with that $12,000, right? If we're going to go to the tables, if we're going to go to the present value of annuity table, I already know what the N is. The N is 10 for the 10 years, but I don't know the I for the interest. So the question is, if I took that $12,000 every year that I received and I invested it, how much money, what percent could I make on that? And the assumption that I'm going to make in this example is that you could invest that $12,000 each year and earn 5%. And so the question is, what's the present value of this annuity where we would get $12,000 every year for the next 10 years? And we could take that $12,000 and invest it at 5%. So my I would be equal to 5 and my N would be equal to 10. Now, what's the present value of the annuity payout? If the present value of the annuity payout is less than $100,000, then we should take the $100,000 lump sum payment today. Because remember, we have two choices, $100,000 today or $12,000 every year for the next 10 years. If the present value of this annuity is greater than $100,000, then we should take the $12,000 payment every year for the next 10 years. And if the present value of this annuity payout is equal to exactly $100,000, that means it doesn't matter because they both have the same present value. So whether you take 100,000 today or 12,000 each year for the next 10 years with a 5% assumption on investment, it doesn't matter because if they're both 100,000, then they're both 100,000. They're equal. So either one you take is going to be the same as the one you don't take. So for this one, we need the present value of annuity table to answer this question. And I've uploaded that into today's Blackboard content folder. So just make sure you're careful when you're opening the PDFs that you're keeping track of the present value, meaning the present value lump sum table. And then this one, the present value of annuity table. Again, notice here in the formula, it's called PVA, just like FVA was future value of annuity in the prior lesson. Notice we have a very similar looking table, percents across the top and across the bottom. We're going to assume 5%. So we're going to take the 5% column and we're going to go all the way down to row 10, n equals 10. And the principal here is going to be $12,000, or what is sometimes called the payment, because we're in an annuity problem. And if I zoom in on that 5% at 10 in the blue rectangle in the lower right-hand corner of the screen is 7.72173. So I'm going to take that factor and multiply by 12,000. When I get that, I get $92,660.76. So that means that if I choose the option of taking $12,000 every year for the next 10 years, and I could invest that money at 5%, that's going to be the same thing as having $92,660.76 right now. However, the other option was just to take $100,000 right now. So would I rather have $92,660.76 right now, or would I rather have $100,000 right now? So the answer is I'm going to take the lump sum payment to me of $100,000 today. For your assignment today, I want you to go back to the same problem that you did in the previous class. This is exercise A3, meaning Appendix 3, A3-11. It's on page 815. In the last class, I asked you to do letters A and B. Today, I'm going to assign letters C and D from that same problem. So again, this is out of Appendix 3. Type your answers directly into Blackboard just like you did in the previous assignment. And as usual, let me know if you have any questions.